Hello, my dear students. Always remember one thing. On the road to success, there is always we, not me. Do not think that you alone can achieve things. There is always another person who is standing behind you. Maybe not coming on the forefront, but behind you, supporting you and praying for you. Never lose that person. Never. Good morning, all. My name is Karthik, your maths tutor, heartily welcoming you all to Vista's learning. So, what will you be learning with V-learning today? So, in today's session, we'll be having a look at minors, cofactors, adjoint of a matrix, and inverse of a matrix. So, these are the core concepts of the fourth chapter of class 12th, Determinants. So, this session will be one of the most important sessions of chapter 4. So moving on with the very first topic, minors. So what are minors? Minor of an element Aij. So what is this, students? Standard way of representing the elements of a matrix. Of a determinant is the determinant obtained by deleting its ith row and jth column. Okay. So we'll demonstrate this, in which element Aij lies. Minor of element Aij is denoted by. So students, make a note of this. So this is a standard way of representing the entries of a matrix, right? So similarly, the minor of the minors are represented by the capital letter M, Ij. So what is written here, we'll just demonstrate on this side, so you will understand it pretty easily. So let us take a determinant of 2 cross 2 first. So this is A11, A12, A21 and A22. Read the definition. Minor of an element Aij. Now let us assume that I want the minor of the element A21. Okay. We need to find out the minor of the element A21, that is nothing but M21. So how do we determine M21? So minor of the element Aij of the determinant is the determinant obtained by deleting its ith row. So the second row, delete that, and jth column. So this is j, right? So this is I and this is j. Ith row and jth column is deleted, and whatever is remaining here, the determinant of this. So determinant of A12. The determinant of A12 is nothing but A12 itself. So M21 is equal to A12. So this is nothing but minor, students. So this minor we have seen for order 2. Now let us see the minor for order 3. So same thing we'll take, but with the numbers this time. Let us take 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now let us assume that I have to find out the minor of the fifth element, or element number 5. So eliminate that 5's row. So this is the 5's row, and eliminate the 5's column. This is the 5's column. So the determinant of the remaining things, that is the determinant of 1, 3, 7, 9. So evaluate this determinant, that will be equal to 9 minus 21, which is equal to minus 12. So this minus 12 is the minor of the element 5. So two small examples we have taken here and understood what is the meaning of minor, one of the most important concepts. Alright, moving on to the next question. Cofactors. So students, when we started evaluating determinants of order 1, 2 and 3, I said your cofactors are nothing but signs. Okay, so there I had to say it like that because we have to evaluate the determinant, right? But actually, what is cofactor here? Cofactor of an element Aij is denoted by, see, the cofactor is denoted by capital Aij. Small aij, entries of a matrix. Capital Aij is nothing but the cofactor, and capital Mij is nothing but what? The minors. Okay. So Aij is defined by, so what is Aij defined by? Aij is defined by nothing but this. So this is what I had told you in the very beginning, or in the very initial stages of determinants. Correct? So minus 1 whole to the power of I plus j. So this is what I said, it is cofactors. But actually cofactors is nothing but minus 1 whole to the power of I plus j into Mij, where Mij is nothing but minor of Aij. So for example, now let us take another example of 2 cross 2. 3, 1, minus 1 and 4. What is the minor of 3? The minor of 3 is nothing but M11 equals, so these both are deleted. What is remaining? 4. Which element is this? A11. So 4 into minus 1 whole to the power of 1 plus 1. So this is only minor, students. So when you consider this whole thing, it will become what? A11. So that is nothing but 1 into 4, which is equal to 4. Are you understanding this? Small aij, standard way of representing the entries of a matrix. Capital Mij, standard way of representing the minors. And capital Aij is nothing but the standard way of representing the cofactors. And what is cofactor equal to? Cofactor is equal to minus 1 whole to the power of I plus j into Mij. Moving on to the next one. So I think we'll solve a small example here. So the example is, find the minors and cofactors of all the elements of the determinant. So this is the given determinant. So we make a note of that here. 1, minus 2, 4 and 3. Correct? 1, minus 2, 4 and 3. So we'll find out the minors first. So what are the elements represented as standard way? A11, A12, A21 and A22. So minor of A11, M11, which is equal to, so these both are deleted. What is remaining? 3. Minor of M12. So these both are deleted. What is remaining? 4. Minor of M21. These both are deleted. Minus 2 is the minor. And the minor of M22, that is nothing but, these both are deleted and it is equal to 1. Correct? Now we'll find out the cofactors. We'll change the color here again. Okay. So these are the minors. So minors are done. Now we'll start with the cofactors. So cofactor of A11 equals minus 1 whole to the power of 1 plus 1 into, what is M11? 3. So this is becoming equal to 3. Next, A12, which is equal to minus 1 whole to the power of 1 plus 2 into 4, which is equal to minus 4. A21, which is equal to minus 1 whole to the power of 2 plus 1 into, what is M21? Minus 2. So this is becoming minus 1 into minus 2. This will give us plus 2. Moving on to the next one, A22 equals minus 1 whole to the power of 2 plus 2 into 1, which is equal to 1 again. So these are what? In the blue color, these are cofactors, where we are multiplying the minor with the sign. Correct? With the sign we are multiplying. And what are minors? Minors are only minors. There is no sign here. Okay, we are only eliminating the particular row and column, and whatever is left out, we are taking the determinant of that. And that determinant is nothing but called as minors. So we have seen the definition, examples of minors and cofactors as well. I hope this is very clear. Moving on to the next one. Adjoint of a matrix. So this is one of the most important concepts. And where is this used? This is used to find out the inverse of a matrix. Alright. So how do we find out the adjoint of the matrix? The adjoint of a square matrix A given by Aij of order n cross n is defined as transpose of the matrix. See this matrix. So first of all, what is given here, students? First of all, a matrix of these kind of entries are given. And what is adjoint? The transpose of this. So what is this called as? Capital A is nothing but called as cofactors Aij of order n cross n, where Aij is the cofactor of the element Aij. Adjoint of the matrix is denoted by Adj space A. So this is called as adjoint of a matrix. Alright. So for example, we'll take one small example here for adjoint. Let us take the square matrix A equals 3, 1, 4, 2. Okay, 3, 1, 4, 2. So we'll find out the adjoint of this matrix now. So read the definition, the adjoint of the square matrix A. So what is the order here? 2 cross 2. Of order n cross n, 2 cross 2 is defined as the transpose of the matrix. So what we have to do here is the first step, take the transpose. whatever square matrix is given here, take the transpose of that. So we will be getting A is equal to 3, 4, 1, 2. So this is your first step, students. Make a note. If you have to find out, or if you are asked to find out the adjoint of a given matrix, the very first step what you have to do is take the transpose of that matrix. After taking the transpose, so we got the transpose of the matrix, right? So here for this matrix you find out the cofactors. Cofactors means what? The sign must be multiplied with the minor, correct? So 3, what is the minor of 3? The minor of 3 is 2, and this 2 must be multiplied with plus. So plus 2 will be the first element here. Next, 4. So this row and this column is gone. What is left out? 1, and 1 must be multiplied with minus. So that will become minus 1. Minor of 1 is 4. 4 must be multiplied with the sign here. That sign is minus again. So 4 into minus is minus 4. And 2, so these both are eliminated. 3 is the one which is remaining, and this must be multiplied with the plus sign here. So that will become plus 3. So you have to conduct 2 steps, students. One is to take out the transpose of the given square matrix, and the second one is after taking out the transpose, whatever transpose matrix you get, find out the cofactors of that. So once you find out the cofactors of that, the resulting matrix is nothing but called as adjoint of A. Okay. So here the same steps, transpose and finding out the cofactors, is also applicable to 3 cross 3 matrix. But there is one small trick here, students. And this trick is only applicable for 2 cross 2. You can find out the adjoint of the matrix of 2 cross 2 in only one step. And how is that? So you have to follow this. So what is the given square matrix? 3, 1, 4, 2, right? 3, 1, 4, 2. So remember, students, this trick is only applicable to 2 cross 2. Do not apply this to 3 cross 3. You will be getting the wrong answer. Okay, it is only applicable to 2 cross 2. How do we find out the adjoint of the matrix? Very simple. Interchange the principal diagonal elements. Interchange them. So what will you get? You will get 2 here and you will get 3 here. Correct? And what you have to do next is exchange the signs or inverse the signs. So here we have what? Plus, right? Here also we have plus. Just inverse those signs. So this will become minus 1 and this will become minus 4. What is this? This is also adjoint of A, and this is a shortcut. So you can use this in your competitive examinations, but in your board examinations always use the conventional method. Do step 1, after that do step 2. Okay, so this trick is only applicable for 2 cross 2, not 3 cross 3. Moving on to the next slide. So here we have one small example. Find the adjoint of matrix A. Here we'll do by shortcut method very quickly. What is the answer? 4, 2. Interchange the principal diagonal elements. Inverse the signs. Minus 3, minus 1. What is this? Adjoint of matrix A. So let us check this whether it is right or wrong by doing the conventional method. So here again, we'll take the transpose of this matrix first. It will become 2, 3, 1 and 4. What is the minor of 2? 4. 4 multiplied with the sign here. Plus, minus, minus, plus. So 4 multiplied with the plus symbol, we'll be getting plus. What is the minor of 1? 3. 3 multiplied with the sign, we'll be getting minus 3. What is the minor of 3? 1. 1 multiplied with the sign, we'll get minus 1. And what is the minor of 4? 2. 2 multiplied with the sign, we'll be getting 2 only. See, check whether these both are right. So what is this step? This is nothing but transpose step 1. And what is this step? This step is nothing but cofactor, finding out the cofactors. So this is step 2. So cofactors means nothing but the minors multiplied with the signs above the entries of a matrix. So this is our cofactors. Moving on to the next one. So there are few theorems based upon the adjoint of the matrix. So you can understand these theorems are in determinants itself. Okay, the very first one, if A be given any square matrix of order n square matrix, then A into adjoint of A is equal to adjoint of A is equal to determinant of A into I. So you can prove this, students. So previous slide. So here if you see we have A, correct? We also have adjoint of A. So if you multiply these both matrices, A into adjoint of A, so this will be equal to adjoint of A into A, that will again be equal to the determinant of A into the identity matrix I. So that can be proved again. So just remember this theorem. If A be any square matrix of order A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. So theorem number 1. So next would be a note here. So remember this, a square matrix A is said to be non-singular. So this question is mostly asked in your boards as well as your competitive examination. So when can we tell a matrix is singular or non-singular? Very simple. A square matrix A is said to be non-singular if the determinant of A is not equal to 0. So you go to the previous slide again here. So let us find out the determinant of A here. So that is A, right? So this is A. What is determinant of A? Determinant of A would be equal to 8 minus 3, which is equal to 5, which is not equal to 0. Therefore, A is non-singular. Understood? If the determinant of A is not equal to 0, it is equal to some other number or integer, then we can tell that the given matrix is non-singular. So, non-singular if determinant of A is not equal to 0, and it is singular if determinant of A is equal to 0. So now you have understood what is the meaning of non-singular and singular. Determinant of A is equal to 0, non-singular. Determinant of A is equal to 0, it is called as singular. Moving on to the next one, theorem 2. So theorem 1 and theorem 2. Second theorem, if A and B are non-singular matrices of the same order, A is also of the same order, B is also of the same order, then AB and BA are also non-singular matrices of the same order. AB means what? Product of two matrices. BA is also the product of two matrices. So the product also will be non-singular only of the same order. So same order means what? So we'll not take any example. So directly matrix A of order 2 cross 2 and matrix B of order 2 cross 2. Can we multiply them? Yes. Why? Because the number of columns of A is equal to the number of rows of B. So here what would be the product of AB? The product of AB would be 2 cross 2. So this will be the order of the product AB. Understood? Singular, non-singular, minors, cofactors, adjoint. 5 concepts we have covered until now. Moving on to the next slide, theorem 3. So here we are saying the determinant of the product of the matrices is equal to the product of their respective determinants. That is, AB is equal to AB when A and B are square matrices of the same order. So we'll read this again, student. The determinant of the product of matrices is equal to the product of the respective determinants. So here what is happening? See this? Determinant of AB is equal to determinant of A into determinant of B. So you can consider one square matrix A of order 2 cross 2 and also another square matrix B of order 2 cross 2. Multiply these both matrices. What would be the order of that product? The order of that product would be 2 cross 2 again. So of this 2 cross 2 product of these both matrices, if you take out the determinant of AB. So let us assume that here you got the value as 10. Alright, here you got the value as 10. Now if you do determinant of A, so some x you will get, okay, and again you find out the determinant of B, here you will get y. If you multiply these both things, x into y, what would be the answer, students? So see here, determinant of AB will be equal to determinant of A into determinant of B, that is nothing but equal to 10 again. Understanding? So this is theorem number 3. We'll just clear out whatever is written on the screen. Okay. Next, theorem number 4. A square matrix A is invertible if and only if A is non-singular. If and only if A is non-singular. So invertible means what, students? So for example, now see this. We have 6, right? What is the inverse of 6? Inverse of 6 is nothing but 1 by 6. Correct? Inverse of 6 is nothing but 1 by 6. Now a square matrix A, what is the inverse of this? It will become 1 by A. Correct? Inverse of square matrix A is nothing but 1 by A. Non-singular means what? Determinant of A is not equal to 0. So if this is equal to 0, then 1 by 0 will be equal to how much? Infinity, right? So that is the only reason they are telling a square matrix A is invertible if and only if A is non-singular matrix. What is the meaning of non-singular? Determinant of A is not equal to 0. Understanding. Moving on to the next slide. So this is one of the example from NCERT. So this will be the last example we'll be solving for today. So this will wind up the most important concepts of the 4th chapter of class 12th. In our next session, we'll be starting with the applications of determinants. So that would be the last topic of that chapter. Then we'll be starting with the next chapter. Okay. So before we end up this session, we'll solve this question, then we'll wind up. Okay. So here, show that the matrix A is equal to 2, 3, 1, 2 satisfies the equation A square minus 4A plus I is equal to 0, where I is 2 cross 2 identity matrix and 0 is 2 cross 2 0 matrix. Using this equation, find A inverse. So using this equation, we have to find out A inverse. Now what is the given equation, students? A square minus 4A plus I equals to 0. Is that correct? A square minus 4A plus I is equal to 0. A we already have here. Find out what is A square. So here we'll write A square equals 2, 3, 1, 2. 2, 3, 1, 2. So multiply these both matrices. So multiply those both matrices. We'll be getting what? A square here, correct? So 2 into 2, 4. Row into column, students. 2 into 2, 4. 3 into 1, 3. So 4 plus 3 is 7. 2 3s are 6. 3 2s are 6. So 6 plus 6 will be equal to 12. 2, 2, 4, 3, 4, 7. So what is this? This is our A square. Next, what do we have here? Minus 4A. So minus 4 times of A. So this will give us minus 4 into 2 is minus 8. Minus 4 into 3 is minus 12. Minus 4 into 1 is minus 4. And minus 4 into 2 is again minus 8. And I is as it is. What is I, students? 1, 1, 0 and 0. So we got this. We got this. We also got this one. We'll just substitute those things here. So A square, what can we write? In the place of A square, we can write 7, 12, 4 and 7. 7, 12, 4 and 7. Plus minus 4 is being multiplied with A, students. Minus 4 is already multiplied with A. So we are writing a plus symbol here. So we'll be getting 8, minus 12, minus 4 and so minus 8, minus 12, minus 4 and minus 8 again. Okay. Plus I is there. What is I? Identity matrix of order 2 cross 2, 1, 1, 0 and 0. Now add all the corresponding elements. 7 plus of minus 8 is minus 1. Minus 1 plus 1 is 0. 12 minus 12, 0. 4 plus of minus 4 is minus 4. So 4 minus 4 is again 0. 7 minus 8 is minus 1. Minus 1 plus 1 is 0 again. So what we have proved now, this equation we have proved. Now using this equation we have to find out A inverse, right? So what we'll do here is, we'll write that equation as it is. A dot A minus 4 times of A plus I is equal to 0. So we have to find out A inverse using this equation. Multiply the whole thing with A inverse. What will happen? A inverse into this. So that will become A dot A inverse minus 4A into A inverse plus I into A inverse equals 0. Solving further, what will happen here? So this is nothing but, we can write it as A inverse only. So this can be written as I and this again can be written as I. 6 into 1, 6. 6 into 1 by 6, 1. 6 into 1 by 6, 1. So we will rewrite this again. So again I into A will become how much, students? A itself. Minus 4I. So this is becoming minus 4I and this is becoming plus A inverse equals to 0. Send these both things on that side. What will we get? We will be getting A inverse equals A minus 4I. Correct? Sorry. Plus 4I minus A will be getting. So if it goes on that side, it will become plus 4I. If plus I goes on that side, it will become minus A. So 4I minus A. So 4I is nothing but 4004 minus, what is A, students? 2312. 2, 3, 1 and 2. So do this operation. What will you be getting? 4 minus 2. 4 minus 2 is 2. 0 minus 3 is minus 3. And finally 0 minus 1 is minus 1. And 4 minus 2 is 2 again. So this will be your A inverse. So we have found out A inverse by using this particular equation. So what is another way to find out A inverse? A inverse can also be found out by using the formula is equal to adjoint of A divided by determinant of A. So this is also another way to find out A inverse. So we have found out A inverse by using this equation. So here we will stop this session. I hope you have understood. Please do tune in into Vista's learning, like and also subscribe. Thank you students. I'll see you in the next class with the last topic of determinants. Until then, stay tuned with Vista's learning. Thank you.